Let's take a look at the fixed order quantity model within a multi-period inventory system. The fixed order quantity model identifies a specific point at an original order replaced and the size of that order. We are going to order when the amount on hand drops below a reorder point. So in this case, we are going to order Q units when inventory reaches reorder point R. So fixed order point quantity, the idea is that we order the same amount every time. So we just need to figure out when we are going to be placing those orders and how much that quantity is going to be every time. As you can see fixed order interval in this figure, inventory is consumed at a constant rate with a new order placed when the reorder point R is reached at the same time. So maybe you place your order every first of month or quarter. And we also need lead time to not vary. Lead time is the time difference placing an order and receiving it. In this case, we will calculate the total cost following the formula. The total cost of ordering is equal to annual demand D times unit cost C plus the quotient of annual demand over the economic order quantity Q times the ordering cost S plus 1/2 of the economic order quantity Q times the holding cost I times the unit cost C. Fixed order quantity, also called economic order quantity, EOQ, is going to be the order size that minimizes the total inventory cost. It includes the cost to order the inventory as well as the cost to hold the inventory. So we need to look at those costs. In this method, we assume that there is no quantity discount. So we can simply go with the quantity that will minimize the ordering cost and the holding cost. Like previous slide, we are going to order fixed order quantity and we just need to figure out when that's going to be and how much that quantity is. It helps us to identify the ideal quantity in terms of purchasing raw materials. Let's take a look at the calculation of total cost. As we previously reviewed, total cost adds up the annual purchase cost plus ordering cost and holding cost. Following the formula as shown here, the total cost of ordering is equal to annual demand D times unit cost C plus the quotient of annual demand over the economic order quantity Q times the ordering cost S plus 1/2 of the economic order quantity Q times the holding cost I times the unit cost C. So to find the optimal order quantity given these things, we need to identify the order quantity at the minimum total cost, which is an inflection point of the curve of the total cost. To solve this problem, we need to differentiate total cost function by Q as shown here. Differentiate total cost by Q is this C is constant, so turn into 0, and Q power minus 1 turn into negative Q power minus 2, so negative ds over Q squared. And QH over 2, Q power reduced by 1, which is just H over 2 times 1, because we've got H over 2 times Q to the power of 0. Therefore, the optimal reorder quantity Q sub up is equal to square root of 2 times annual demand D times the ordering cost S divided by the holding cost H. Optimal order quantity can be also found when annual ordering cost equals annual holding cost as shown in this figure. We will demonstrate the fixed order quantity model in this exercise 11.2. In this example, the part is ordered whenever the inventory drops to reordered quantity, which means we need to determine a desirable reordered quantity and the reorder point for the system. We will use the formula for optimal order quantity to calculate a reorder quantity. The optimal reorder quantity Q sub up is equal to square root of 2 times annual demand D times the ordering cost S divided by the holding cost H. For this part, annual demand is 1,000 units and ordering cost is $5 per order and holding cost is $1.25 per unit per year. So based on this information, we can compute the optimal reorder quantity Q sub up, that is equal to square root of 2 times 1,000 units times $5 divided by $1.25 per unit per year. We get a result of 89.44. Therefore, rounding off, reorder quantity of this part is 89 units. Next, we will apply straightforward formula to calculate the reorder point R. The formula for reorder point R is the average daily demand D bar times lead time. For this part, average daily demand is 1000 divided by 365 days is equal to 2.74 units, and lead time is 5 days. Substituting these values into the equation, 2.74 times 5, we get a result of 13.7. Therefore, rounding up, the reorder point is 14 units. Next, to compute the total cost of this order, likewise substituting these values into the formula, the total cost equal annual demand 1000 times cost per unit 12.5 plus annual demand 1000 times ordering cost 5 divided by Q sub up 89 plus half of Q sub up 89 times holding cost 1.25, which is 12,611.81 in this case.